derivative.
How can you tell it's a derivative?
Because it's like the midpoint method.
Right. Okay, so here is a very interesting discovery is that the PDF looks like the midpoint method of taking the derivative of something, right? Because we are dividing by 2 delta x. So can somebody help figure out it's actually the derivative of what?
Cumulative.
Well, if you have learned something like this in your previous statistics class, which some of you may have, right? So who have already studied the PDF and CDFs previously? So all of you have. So it's actually the derivative of the CDF, the cumulative distribution function. So the CDF of x is actually the limit of number of samples goes to infinity. So there is no longer delta x goes to 0 because we are basically not using the derivative anymore. The limit of number of samples in minus infinity to x, right, divided by the total number of samples. So that's the cumulative density function we are looking at. All right, I said in MATLAB there is a very natural way of plotting the CDF. Can somebody again think of how do you do that?
If you say just plot wind.
Huh? What if I just plot wind? That's what I get.
You could possibly like never mind.
Okay, here's the answer.
Oh, I see.
Right? So okay, so it's actually not exactly on the answer because it's not the CDF. The CDF should be the transpose of this plot. Right? But like what I'm doing is really I'm plotting really what's called the order statistics of the data. It's called the order statistics because I had it sorted, right? So if you want to figure out, for example, what is the median of the wind, you just look over here. If you want to figure out what is the 95th percentile of the wind, just look at like about 95%. If you want to figure out what is the tolerance of my quadcopter, if I want to be able to fly for 99% of the time, what you do is just sort the data and take a look at what is the 95th or 99th percentile of the data after you sort it. Or in another way, if I want to really plot the CDF, or approximately the CDF, here would be link space. I would use the sorted wind as the x-axis and the link space, and with the length of wind being the y-axis. So here would be a proper cumulative distribution function, because the x-axis is now my x, and if I look at any vertical point, this is the likelihood, right, and of the wind being slower than that particular value, right? So that's basically the CDF. And okay, so now in this case, it's pretty simple that if you just look at the property of the data in terms of its distribution, PDF or CDF, you can look at the integral of the PDF, which you can look using the histogram, right? Or you can just figure out what is the CDF. Or you can just sort all the data and look at the percentile. You can figure out your answer. You can figure out how how big my quadcopter has to be to able to overcome the wind for 99% of the time. So good. We don't really need any Monte Carlo method to figure that out. Okay? So now, but here becomes here's like in a typical engineering situation, the question you are asking goes from the simplest to more and more complex. Now imagine your quadcopter doesn't just have to overcome the wind, it has to overcome the wind while carrying the payload, right? It has to actually carry whatever you have to deliver and fly in the wind. Then what do you do? How do you figure out what kind of quadcopter you want to design so that you are able to carry the payload and fly for 99% of the time? Now it becomes not so easy anymore, right? So why don't we have a discussion and figure out what's the solution you would propose for designing that quadcopter?
Well, you'd have to figure out. Wait, so the payload is also a random variable?
The payload, yeah. So that's a good question. Is the payload also a random variable?
And like, what sort of distribution does the payload like have? Kind of matters. Because if it's a random variable and its 99th percentile is like well within the, substantially lower, like depending on where its 99th percentile is, depends on matters to where we pick the wind, acceptable wind loads.
Right. So that's actually a very good first question to ask is what kind of weight do you want to deliver, right? So if I want to, you have very different designs. If I want you to carry a 10 kilogram payload versus a 1 kilogram payload, right? So the first thing is to figure out what's the amount of payload you want to carry, and also can you gather some data to figure out what are the typical payload you have to carry within that limit. All right, so here I have collected also some artificial data on the weight that you customer typically orders, right? Maybe I'm sure if you go to Amazon has that data available for you. So here, if I load that data, what do you want me to do with that weights? So here, my weight is now it has 1,895 samples or random samples of the weight our customer has ordered, and within a maximum, let's say within the maximum limit of 1 kilogram. How do you want to look at the data?
CDF, plot sort.
Okay, so plot sort my weight. Is that what you want to do? So here's the ordered weight of my payload, right? So from the basically almost nothing to with the upper limit of 1 kilogram. So if that's kind of if that's representative of what I have to carry in the future, how would you go ahead and design your quadcopter?
It's like the probability of, you can find the 99th percentile of the joint distribution. Okay,
so let's actually, can you form, since we have 5 people, can you form 2 groups and each come up with a strategy for going and designing that quadcopter to satisfy that design criteria?